n is our power, which is 8. X is our base here. And then we subtract 1 from the power. That's the general method when you're differentiating. So in this case, our power is 8. Our base is x. And if we say 8 minus 1, it will be 7. And this becomes dy dx. N is the power, x is our base, and base is 0 is constant. We leave it there. We only play around with the power. We multiply the power, and then we subtract 1 from the power here to get the new power. To get the new power, we say n minus 1. Is that fine?
Yes.
And then what if you're given your function y equals to 2x? How can you work out that? Okay, let me ask you a question. What's our power in this function? What's the power in that function? Are you guys seeing the screen?
Yes.
So what's the power in that function? X is to what power?
Actually, I've not understood everything.
Okay, let me restart. So I said you're looking at a topic called differentiation. And differentiation is the change in the parameter with respect to another parameter. Change in one parameter with respect to another parameter. If you're given a function, let's say y equals to x to power n, we use the general method to differentiate such a function. And the general method is given by differentiating this. When you differentiate y, we get y dx. Since we're differentiating y with respect to x, it's given by dy dx. dy dx is the change in y with respect to x. And to get the derivative of this function, we said we multiply with the power. We bring the power down, so it comes here. We multiply with the power. We keep the x, and then to get the new power, we say n minus 1. We subtract 1 from the old power to get the new power. N minus 1 will be our new power. Does that make sense?
Yes.
So have you memorized the general method? We multiply by the power, and then to get the new power of x, we subtract the old power minus 1.
Okay.
So if you're given a function y equals to 2x, what's our power in this function?
It will be 2 times 2 power 1.
I'm asking for the power in this function. What's the power of x?
The power is 0.
0.
The power can't be 0 because if you remember very well, was it
The
indices?
power is 1.
The power is 1. If the power is 0, any number to power 0 is 1. But in this case, our power will be 1. So to get the derivative, it will be dy dx. So you said our power is 1, so we multiply it. So it will be 1 times 2x. And we have 1 as our power, so we shall say 1 minus 1 according to the general method. Is that fine? Is this part fine? The second part?
Yes.
Yes.
So we shall get our 2x to power 0. And you know that every number to power 0 is 1. Please note that any number to power 0 is 1. So it will be 2 times 1, which will give us 2. That will be our dy dx. I hope that's fine. Is that fine?
Yes. Teacher, from here, our n is 2.
Yes. No? Our n
Mm.
in this case is 1. The power. Sorry, let me put it back. So we have our function is 2x. N is 0 is the power of x. Is that clear?
Yes.
But in this function, x has a power of 1. That's why we multiplied it. In this case, our base is 2x, which is where it's kept constant. The only thing we do with the base is we multiply it by the old power to get the new base. Is that okay? We are multiplying that old power times the base, and you're subtracting 1 from the old power to get the new power. Is that okay?
It's okay.
If you have a question, you can please tell me. I can't read the chats. You use your microphones because I'm sharing from the screen. I can't see the chat. So in case you have any question, you use your microphone. Can you go to example? Can you go to another example?
Yes.
Yes.
Then what if you're given a function 3x to the power 5? How can you differentiate this? Before you start differentiating, you have to first see what's my power and what's the base in this function. Those are the first things you look at. Here you see the base is 3x, and you see that our power is 5. Our power is 5, which is n in this general method, and our x is 3x, which is the base. So what's the answer?
It will be 9 power 4.
Why 9?
That we shall multiply 3 times 3 raised to power. No, it will be 9 power. Okay, 3 times 3 raised to that power of 5 minus 1, which is 9 raised to power 4.
Oh, okay. Then where are you getting that 3 to multiply it with 3?
At the base 3. N.
No, n is our power. In this case, our power is 5.
Okay.
N is the power which we multiply. In this function, 3x is the base.
Okay.
So it will be 5 times 3x to power 5 minus 1. Is that fine? Please, let's use the general method. 5 is our power, and we said n is the power. In this case, 5 is our n, and 3x is our x, according to the general method. Does that make sense? Yes, pardon, I didn't hear. Guys, have you understood how to use the method, or should I repeat it?
Teacher, if first, pardon.
Okay, let me repeat. So to use the general method, we use this. Rather, to differentiate a function, we use the general method, which is n. Okay, let me repeat it. N is the power. X is the base. So the general method in this case, we said we multiply the power with the base. Is that fine?
Yes.
We multiply the power with the base. But to get the new power, we say n minus 1 in order to get the new power. Let me repeat again. We multiply the old power by the base. And to get the new power, we say n minus 1. Is that fine?
Yes.
And the base won't always be x. It could be 2x, 3x, 4x, anything. Is that fine?
Yes.
Okay, now let's use the function y equals to 2x to power 3 power 3 over 2. What's our power in this function? The function is y equals to 2x to power 3 over 2. So in this case, our n, what is it? The power? What's the power that you see in this function?
3 out of 2.
3 out of 2.
And then our base, what is it?
2x.
Yes. So we say to get the derivative, it will be dy dx, dy over dx. So we said we bring the power and we multiply it with the base, isn't it? So
Yes.
3 over 2 times 2x. I hope that's fine.
Yes.
And
Yeah,
then we
it's
say
coming.
to get the new power, we said n minus 1. So in this case, it will be 3 over 2 minus 1. Is that fine?
Yes.
So that will be the answer, n1 with a curve. So here I see that 2 cancel out. What's 3 over 2 minus 1? Isn't it a half? Is that correct? 3 over 2 is 3 over 2 minus 1 is a half, isn't it?
Yes.
So I hope that's fine. Have you now understood how to use the general method in order to differentiate?
Yes.
You first look out for the power and then you look out for the base. Let's use another example. Now, what if you're given y equals 3 the cube root of x? Any volunteer to work it out for us? Any volunteer to tell us how best we can work this out? But let me first give you a hint. Before you work out this, we have to first express it in index form. So we are going to remove it from index form. So how best can you put this x up to make it like the functions you were seeing before, and remove it from this fraction form. How can you remove it from this fraction form and put it in the function that we were seeing, for instance, y equals to 3x, such a function? How can you get rid of the fraction? Anyone who has an idea on how we can bring the cube root of x here up to get rid of the denominator? Have you ever seen something like this?
No.
Let me see. Or have you ever seen something like the square root of x? The square root of x is the same as this. Do you all agree?
Yes.
And then what if it was 1 over the square root of x? Okay, this is how it is. If you're given a square root, okay, let's say if you're given a third and it's our denominator, the only way to get rid of it, to remove it from the fraction form, for instance, you have 1 over the square root of x. This is the same as x to power negative a half. You looked at these things in senior 5 first term when you were talking about surds, indices and surds. That's where it's found. If you want to change this from a fraction, it becomes this. You mean none of you has ever seen that? Have, please mute yourself, mute yourself. Please mute yourself. So we are looking at the part where we have our square root as the denominator and you want to get rid of it as a denominator. You want to write it as a function or but mwalimu ndio ndio sida. Tati limu ndio mwalimu. Ano di bar nge. So every time you're given 1 over the square root of x, it can be written as x to power the negative a half. Or for instance, if you're given a cube root, if it's 1 over the cube root of x, it's the same thing as saying x to power negative 1 over 3. Or if they give you this part when it's 4, it's the same thing as saying x to power negative 4. Please note that if we want to change a third that is in fraction form, we keep the base that's under the square root. We keep that number, but then this part for the root, it becomes a negative. We power it to a negative. So in this case, if we're given 1 over the root of 4, we keep whatever is under the square root. This is x. Then we power it to the negative of the root that's given. In this case, we are given the fourth root. So it will become to power negative 4 over, sorry, negative 1 over 4. Or we could call it negative a half. That is under the topic of indices and sides. Same as x to power the negative of the root. So in this case, we have the root of 3. So it's the same as y equals to 3x to power negative a third. I hope that's fine. Can I continue?
It's okay.
Please go back and review the indices and sides. So in order to differentiate this, it becomes dy dx. What's our power in this case?
Negative a third.
So we multiply it by the base, which is 3x. And then we say the power given minus 1, which will be negative a third, minus 1, which will eventually be, the 3 cancels out. Please be careful with the negative. Don't forget it, so it becomes negative x to power negative 1 over 3 minus 1 is negative 4 over 3. Is that fine? Can you continue?
Yes.
Okay.
Yes, teacher.
Now, what if you're given such if y equals to x? Sorry, if y equals to 6. So in this case, we are not seeing x anywhere, are we?
What?
So you're given y equals to 6. We are not seeing x anywhere. So this is the same as so these two are the same. Y equals to 6 is the same as y equals to 6 x to power 0. Why do I say it's the same? Because any number to power 0 is 1. Is that fine? Are you seeing where this is coming from? You're told to find dy dx, but you don't see any x anywhere. They have given you y equals to 6. But remember, in indices, they said any number to power 0 is 1. So that means our x, in this case, was powered to 0. Is that fine?
Yes, it's fine.
So in this case, our dy dx. So here our power is 0. So we shall say 0 times 6x to power 0 minus 1. And any number multiplied by 0 is 0. So in this case, our dy dx is 0. There is something to note about this. Every time you're given a constant, in fact, these are constants. You could be given 6 or 1 or 2 or 3 or 54 or 60. Those are constants. Any number is a constant if it's not multiplied by any parameter or variable. Variable or parameter can be the form of 2x, 3x, but if you're given 6, 1, or 2 without any x or any parameter, it's a constant. It's called a constant. And when they're differentiating constants, the answer is 0 is 0. The dy dx of a constant is 0 is 0. Please take note of that. Was that fine?
Yeah.
And then what if you're given a function like y equals to x? What's our power? What's the power in this function? Please
It's 1.
respond. What? And you said you multiply the old power by the base, so 1 times x. Then we shall have our 1 minus 1 x to power 0, which equals to 1. So every time you see when your function equals to y equals to x, or you can have y equals to m, the answer will always be 1, the derivative will always be 1. Why? Because its power, it has a power of 1, which you multiply it by the base, and the new power is got by subtracting 1 from the old power, which gave us 1 times x gave us x, and 1 minus 1 gave us 0. And any number to power 0 according to the laws of indices is 1. Is that okay? Can we continue?
Yes.
Now we are going to look at functions that involve sum and differences, or we could call them polynomials. Let's say y equals to 3x cubed minus 4x squared. Please, has everyone understood? If you have a question, I can go back and explain it.
So I've got you.
Plus 5x minus 2. So when you find such a function and you're told to find the derivative, you first write your dy dx. Since you're differentiating y with respect to x, dy over dx. Now you're going to work out this one by one. So I'm going to first work out this 3x to power 3. What will be our derivative of 3x to power 3? What's the derivative of this function? 3x cubed.
9x power 2.
Okay, that's correct. I hope everyone knows how she got 9x to power 2. Minus, you keep the sign. So what's 4x squared? That's the derivative of 4x squared.
8x.
Pardon?
Hmm?
What's the derivative of 4x squared? Guys, please respond.
8.
Yes. What about the derivative of 5x?
5.
Yes, that's correct. And the derivative of 2?
0.
So that will be our derivative of that function. Is that okay with everyone? Can I continue?
How do you get the derivative?
By differentiating the function. This function is called the derivative. The answer you get after differentiating is called the derivative. Differences, or we could call them polynomials. We work out one by one. So in this case, we had 3x cubed. We got the derivative of this as 9x squared minus the derivative of 4x squared is 8x, and the derivative of 5x is 5, and the derivative of 2, which is a constant, is 0. Can I continue?
So how did you get the derivative of 3x power 3?
Of 3x to power 3?
Yes.
So you have 3x to power 3. Our power is 3. So we shall say 3 times 3x to power 3 minus 1. And 3 times 3 is 9. X to power 2. Are you seeing where we got it? Do you see where it comes from? The person who asked the question.
Yes.
So can I continue? Has everyone understood? Please, if you have a question, please ask and I'll go back and explain it. Can I continue? Can I continue?
It's okay.
Now we are going to go and look at simple product and quotients. We're going to look when you're given product. For instance, you're told to find that to differentiate this function x squared into x minus 2. I hope we all know how to open brackets. So when you're given, one thing to do when you're given a product, you're going to open up bracket so that you can change it to more of a sum or a difference equation, the one that we have looked at before, we have just looked at. I hope everyone knows how to open up brackets. So this x squared times x. Right. It will be x squared times x minus 2x squared. I hope you all know how to open up brackets. Here using, when we use the laws of indices, here we have x squared times x, the same base, and it's a product. What happens to the powers? We add. Minus 2x squared. Is that fine? Is that fine?
Yes.
So now we are going to go ahead and differentiate the function. Since you have written it in simpler terms, dy dx. So the derivative of x cubed, what will it be? What's the derivative of x cubed?
3x power 2.
And what's the derivative of 2x squared?
Four x.
So that's it. Has everyone understood it?
Yes.
Please, if you have a question or have not understood anything, please ask. So let's look at another example. When you're given ry as x squared plus x into x. Someone open up brackets. We open up brackets together. So it will be x squared do we all know how to open up brackets, or should I assume everyone here on the platform knows how to open up brackets?
No.
No.
So when you're given such brackets, x squared plus x into x plus 1. Do you remember the equations that we had when we had a plus b into a plus b? Have you ever seen such? So in order
Yes.
to open up, remember we have to multiply. And let me use this example. If you have a into a plus b, you're supposed to multiply a by every number that's in the brackets. A squared plus ab. So this is what you're going to do here. So you shall first take out a. Then we use this second bracket, a plus b, plus b into a plus b, which is a squared plus ab plus ba plus b squared. I hope you're all following. A squared plus 2ab plus b squared. So we are going to open up brackets the same way I've opened up these ones here. So we have x squared plus x into x plus 1. You can begin any side you want, any side you see that's easier, any bracket you see that's easier. If you open up and you multiply it into the other bracket, which one is easier? So let's take this as our first bracket and this as our second bracket. So we shall say x squared into x plus 1 plus this x into x plus 1. Is that fine? We multiply this into the brackets, and then you also multiply this into the brackets. We shouldn't leave out any. Is this fine? Is this step fine?
Yes.
So it will be x cubed, and then x squared times 1 will be x squared. Please, whenever you're opening up brackets, take note of the signs. Plus, we do the same here, x times x squared into x times 1, which is x. So we see that we have only one x cubed, plus we have two x squared, so there will be 2x squared plus x. I hope that's fine. Is that fine?
Yes.
Now let's go ahead and differentiate it. dy dx. What's the derivative of x cubed?
3x power 2.
What's the derivative of 2x squared?
What
And what's the derivative of x?
Zero.
So that's our derivative of this function. 3x squared plus 4x plus 1. Has everyone understood? If I head to the question, has everyone understood before I erase the board?
Yes, we have.
So let's do an example when you're given a quotient. Y plus 2x squared What are you going to first do in this case? If you're given such a fraction, you're told to differentiate. What are we going to do? When you're given fractions, you first see how best can I simplify this fraction, so that I can write it in the form of x to power n. How best can I write this fraction? So come here. This is the same as, say, x squared over x plus x over x. And then according to the laws of indices, the same base, different powers, x squared over x is the same as x to power 2 minus 1, which is the same as x plus 1. We have simplified it in a manner that's simpler to differentiate. So this is the same as this. Anyone opposing? Or should we continue? This is the same as this. Do you all agree?
Yes.
So to get our dy dx, what's the derivative of 1? Sorry, of x? When you differentiate x, what do you get? What do you get when you differentiate x?
1.
And what do you differentiate? What do you get when you differentiate 1? Remember, this is our constant. What do you get when you differentiate a constant?
0.
So in this case, our dy dx is 1. Is that fine with you all?
Yes.
Can I continue?
Yes.
So now we're going to look at a topic called second derivatives, a subtopic. We're going to look at second derivatives or second differentiation or higher derivatives. They are sometimes called higher derivatives. So now you're looking at second derivatives. It's actually the same as differentiating, but in this case, when they say second derivative or they say differentiate for the second time or find the second derivative, we are going to differentiate 2 times. We're going to first differentiate, then redifferentiate what we have differentiated. We are going to differentiate a function, then we shall get a derivative. Then we shall redifferentiate the derivative that we have got. Does that make sense? Should we use an example? Before we head to the example, second derivatives are written as d squared y over dx squared, or they can be written as f second prime of x, depending on the parameters given. Here, I'm assuming we have been given a parameter y with respect to x. That's why I'm saying d squared x over dx squared, and it's also the same as f double prime x. This is the same as saying the second derivative of a function. It's the same as saying the second derivative of a function. That's how we express it. And every time you're writing your answer, when you're told to differentiate, please always write the dy dx, or if they tell you to find the second derivative, please always make sure you write d squared y over dx squared, or you could just write f double prime. For first derivative, it's dy dx, or you could write f prime x. This is for the first derivatives, this is for the second derivative. So let's see this best using an example. So let's say you're told to find the second derivative of this function y equals to x to power 3, which you already looked at. We already looked at this example, and we said our dy dx was the power is 3, bring down the power, multiplied by the base, 3x, and then you said you subtract 1 from the power to get the new power, which becomes 2. 3 minus 1 is 2. So to get the second derivative, d squared y over dx squared will be, now we are going to differentiate this. So it becomes 6x. Is that fine? Please always make sure you, whenever you're getting the second derivative, we are differentiating the first derivative, not this. When you differentiate the function, you get the first derivative, which is 3x squared. And then to get the second derivative, d squared y over dx squared, we differentiate this. Is that fine?
Yes.
No.
Where haven't you understood? The person who said no, where is the problem? Since the person who said no is not asking the question, let's continue. We're going to use the same examples we had previously. So what if you're given y as 3x to power 5, and they want you to find f double prime of x? That's the second derivative. What will our first derivative be? What will our dy dx be? Since I said the steps of finding the second derivative, we first find the first derivative. Then to get the second derivative, we differentiate the first derivative. So in this case, we need to get the first derivative. So what's our dy dx? What's dy dx?
15x
15x to power 4. So what will be our second derivative? Please, it's always d squared y over dx squared. Don't write dy squared over. No, this is not second derivative. This is wrong. It's d squared y over dx squared. Please take note of that. If you find this hectic, or you might forget it, just say f double prime of the parameter given. So when you differentiate the first derivative, what do you get? 15x to power 4. What will you get? Class, guys, are you there? What do you get when you differentiate 15x to power 4? What do you get when you differentiate 15x to power 4?
225 to power 3.
Where are you getting 225? What's 15 times 4?
60.
Yes, we said the power multiplied by the base. 15x times 4 will be 60x. And then the new power, we said it's 4 minus 1, which will be 3. I don't know how you got that 220. Is it 5? But just make sure you remember the general method. If you remember the general method, then it will be easy for you to differentiate all these. Is that okay?
Yes.
Yes.
Should we do another example, or are you guys tired?
Another example.
We can do another.
So you have y plus 3x cubed minus 4x squared plus 5x minus 2. What's our dy dx here?
Nine x plus
9x to power
2.
and then what's the derivative of 4x squared?
8x.
8x.
What's the derivative of 5x?
5.
We are here. What do you get when you differentiate 5x?
5.
And then what do we get when you differentiate a constant?
0.
Yes, so this is our first derivative. And I said to get the second derivative, we differentiate this. Okay? D squared y over dx squared. So what do we get when we differentiate 9x squared? What do you get when you differentiate 9x squared?
18x.
What do you get when you differentiate 8x?
8.
And what do you get when you differentiate 5? 5? What do you get when you differentiate 5? 5
5.
is a constant. 5 is a constant, so it's 0.
0.
So this is our second derivative. Is that okay?
Yes.
Yes, madam.
Okay, anyone who saw any derivative anywhere that they couldn't work out and they want help? Or anyone who has a question about what you have studied today? Or should I assume everyone has understood?
Yes.
So there is no question about differentiation you came across and you failed to work it out. They told you to find the derivative.
Excuse me, madam.
Yes.
Can they ask you a question when like it's having a root somewhere?
When they told you to differentiate.
Yeah.
Yes. We looked at it.
For the second derivative.
Yes. Just an example. The one we looked at before was y equals to root of x. And you know that root of x is the same as x to power a half, right?
Yes.
So to find the first derivative, dy dx will be a half x into a half minus 1 This is the same as a half x to power negative a half, right?
Yes.
And then to get the second derivative, we say d squared y over dx squared will give us, so we shall bring our negative a half and multiply it by a half x, which will give us negative a quarter. I hope that's fine. To power x into negative a half. Let me write it properly so that you see. So in this case, we have our dy dx is a half x to power negative a half. That's where we were. So now to get the second derivative, d squared y over dx squared equals to. So to differentiate this the second time, remember this negative a half is our power. So we shall bring it down, negative a half times a half x to the power negative a half minus 1. Hope that's fine. So it will give us negative a quarter. X to the power what's negative a half minus 1?
Yes.
What's negative a half minus 1?
Negative 3 out of 2.
Yes. So that will be our as long as you know how to express a root. Let me write it here. This is the same as x to power a half. The same as x to power a third, isn't it? X to power negative a quarter. So there are things you should memorize. So that's all for today's lesson. I hope you guys have learned how to use the general method, how to differentiate polynomials, the sums and the differences, the product and the quotient, as well as how to find the second derivative of all functions. Any function you'll be given, I hope you'll be able to find the first derivative as well as the second derivative. Is that okay?
Yes.
Okay, thank you very much for attending. That was all for today's lesson.